Good morning, friends. Welcome to the Science Show on Akulmach Live. And, we know that India has achieved another feather in the cap by launching Chandrayaan-3, which is the third lunar mission from India. And just like the previous one, the Indian ISRO is trying to make a soft landing on the surface of the moon. And this requires a lot of precision based launching of the vehicle, and also control throughout the journey to the surface of the moon. And this has to be very precisely calculated using all the mathematical formulas available to the mankind, to the scientist. Therefore, we already know that after the launch, Chandrayaan was in the lower Earth orbit. Then later the Earth orbit was escalated to higher Earth orbit. That means when you're doing that, you're increasing the speed so that the gravity of Earth loses little bit of grip on the spacecraft. And when that happens, then the spacecraft will actually increase in orbit. And once the orbit increases, then there will be a time when the spacecraft will be so far off from the Earth that the Earth gravity will become very low. So that will be the time to fire it towards the moon. And all these steps have already happened like a clockwork. Now it is in open space. It is moving towards the moon. So the next level of challenge is re-entry into moon's orbit. Now, how that will happen. For that, let us go back to the scientific community and look at the formula. We already know the mass of the Earth and the gravity. Right from this childhood days, we have actually done so many experiments where the gravitational forces of Earth were we were asked to calculate. When we were like 12-13 years old, we knew how to calculate the gravity of the Earth. Using the same formula, you can find out the applicable gravity of the moon. And we know that most of the people who are educated, they know that moon's gravity is 1/6 of the Earth's gravity. That means it is less gravity, and it is less by sixth part. So if the gravity of Earth is 100, then the gravity of moon is 15. Just to apply the same mathematics. So it is 1/6 of the gravity of the Earth. So considering that, if the spacecraft is moving towards the moon, we have to basically align this spacecraft in such a way, in that direction, that it is caught by the gravity of the moon. Because it is now released from the gravity of the Earth, it is now moving towards the moon. It will be captured by the gravity of the moon. If it doesn't capture, then the spacecraft will never be able to move in the orbit of the moon. There are two things that can happen. One is the spacecraft will actually keep moving in straight line and will be lost in open space. Number two, if the trajectory angle of moving towards the moon is very, very shallow, then it may crash. Instead of going into the orbit, it will actually directly enter the moon's gravity well and then crash on the surface of the moon. So this next challenge is very, very critical for Chandrayaan-3. And let us look at what are the mathematical formula. So most of the people who have studied science, they know that every body in the universe attracts the other body, and this is defined by this formula called G, which is a gravitational constant. G remains constant throughout the universe, so wherever you are, you can safely apply G. It's a very, very low value. However, mass of object 1 multiplied by mass of object 2 divided by r square. So further the distance between the bodies, the less gravitational impact they will have on each other. So if you are very far off, that is why you don't feel the gravity of Jupiter on Earth, because it is very far off. Why? Because if you are away from Earth, or away from one body is away from the other body by say factor of 1, but the gravitational effect will be square of that. as it is explained by r square. So the gravitational force is at least half of that, the distance compared to the distance. So this is explained by this formula. This was given to us by Newton way back, almost 400 years back. So we know what is the method for sending our spacecraft into open space, and this formula actually defines that. And using this formula plus a lot of other complicated math, the ISRO scientists have actually plotted the trajectory, and they are monitoring it very minutely, because this next step is very, very critical. The moon has to capture Chandrayaan-3 orbiter into the orbit, because if does not happen, then it could become a failure. So therefore this is a very, very critical step. The next step is very, very critical, and this I'm trying to show here that this is how the orbit of the Chandrayaan was escalated into higher orbit gradually after each burn. In order to upgrade the orbit, the engine was started so that the speed can be increased, and once the speed increases, it will create extra momentum, and once the extra momentum is created to the spacecraft, attributed to the spacecraft would Earth gravity would require more force to stop this spacecraft wandering into the space. So what will happen? It will compensate, and the orbit will increase, so much so that it start reaching the moon's orbit. And at this point in time, as the last line, green color line, is depicting, when it is passing by a moon, it has to be captured by the moon's gravity. So once it captures into moon's gravity, it will then form the other loop, an elliptical orbit around the moon at certain speed, and subsequently this speed will be reduced further to bring it down to a reasonable level, a near circular orbit. So this is a step that scientists will have to ensure that Chandrayaan onboard computer and all the machinery works properly, and it is captured by the moon. Once it is captured by the moon, then the next maneuver of reducing the speed, that means firing of the engine in such a way that the speed of the spacecraft is reduced. And once the speed reduces, the influence of the moon's gravity increases. And once that happens, then it will start actually reducing in the orbit, and it will start orbiting much closer to the surface of the moon. And the speed will also be slow. So when the speed is slowed down, then it will be easier for a lander, because if you actually land at a higher speed, start the maneuver at higher speed, then the chances are it's very difficult to control. Then slowing down of the lander spacecraft will be very difficult. So these are all very complicated maneuvers that Chandrayaan is going to do. But right now, the next maneuver is very critical, where the moon has to capture the spacecraft into its orbit. And that is why, let us cross our finger, let us pray. And if you're Indian, let's provide your good wishes for the success of this mission, because this step is very, very critical. So friends, if you have any question on this, any clarification or any observation on this subject, feel free to send it across. We will read in the next edition of Science Show. Until then, please take care. Let us pray for the success of Chandrayaan, because this next step is quite challenging. I'm sure scientists are looking for it, but let us provide our blessings to this spacecraft so that it successfully complete this maneuver and fall into the orbit of moon. All right, friends, have a nice day. I will catch you in the next one.